Good evening, everyone. Thank you for coming. These talks are recorded. They're on. There's a link that I will send round, and so look at the back catalogue if you've got a moment. Look, thanks for coming, and I would just like to welcome Sian Ricketts from Carmody Groarke. Really interesting practice. Have a look at their work. Lovely project in Helensburgh, up in Scotland, just outside Glasgow. Amazing Charles Rennie Mackintosh house being restored, and they've built this kind of mad steel shed over the thing. It's brutal, but it's good. It's very good, very interesting. But tonight, I think Sian's going to tell us a little bit about the Gent waste brick, and actually building with construction waste, and it's possible. So I think all the things that you're thinking about in terms of reuse, recycling, upcycling, growing things, whatever, you just mustn't think any of this stuff is mad. It's not, it's happening, I think, a bit, and it's going to happen more. And so it's just really nice to have Sian coming and talking about a project which sounds like a good idea, but it's a good idea that is actually happening for real. So thanks so much for coming in. Really appreciate it. Thank you.
Thank you. All right, can everyone hear me? Great. Do I need to hang away from this other microphone? Is that going to...
It's off.
It's off. Okay, good. All right. Okay, so very nice to be here. I'm going to talk about some rubbish buildings, because contrary to that introduction, that's what we do. So yes, we are Carmody Groarke. We are about a practice of about 45 people. We've just moved into a new office in Smithfield Market, not in the meat cutting area of the market. You'll be pleased to know we're up in the loft, which is on the. We work on a range of different projects. We focus a lot on kind of cultural projects. So we've got the Hill House box up in Helensburgh, which Will was just referencing there. We've got a design museum that's on site at the moment in Gent, which I'll talk more about in a moment. We did some work for the BFI. New frontage, new cafe there. We do sort of housing projects and it's student housing, so it's not quite residential, but student housing project in Milan, which has been completed. We're doing some work in Manchester for the Museum of Science and Industry up there. We made a theatre particularly for Harry Potter experience theatre in Germany. We're working with the British Library, and also one of our sort of widest known projects is Windermere Jetty Museum, which was nominated for the Sterling Prize a year ago, and that is complete, and that is in Cumbria. But today I'm going to talk to you about bricks. We've got a kind of standard brick over there on the left-hand side, and a different brick, which we'll talk about. And the kind of context underpinning all of this conversation is really the climate crisis, and I'm sure that's like high up on your curriculum. It wasn't so much when I was studying, so it's gaining attention, which is great. But I guess the kind of takeaway, and I'm sure you all know this, but the building and construction industry is responsible for approximately 40% of global CO2 emissions. If we look at average UK citizen, you produce around 10 tonnes of CO2 embodied carbon per year. If you compare that to a medium-sized cultural building, it's about 6,000 tonnes of CO2e. So all of that is to kind of hammer home the fact that your professional impact and our professional impact is absolutely massive. And I think that comes with an element of responsibility. I think we are in an incredibly privileged position as architects and as designers and people working in the construction industry to really make a huge impact through our professional through our professional decisions that other people in different professions are not necessarily able to make. So as I said, this talk is focused on bricks and how we can take what is typically a very high carbon material, so a brick, and actually make that a lower carbon material. We started working with bricks at a time of kind of mass production, at a time of cheap energy. So if you think about when bricks were first sort of coming into, bricks have been around for thousands of years, but the mass production of bricks came at a time when, the Victorian mass production of things when we were able to get energy really, really cheaply. And that has really sort of proliferated throughout the last 20th and 21st century. What we also know is that the regulations that we now adhered to were sort of written at a time of really cheap energy. So when we're thinking about materials and when we're thinking about writing kind of codes and how best to use those materials, there's not necessarily any thought of producing materials that are sort of lower in terms of their embodied energy and of their environmental impact. So this is one of our buildings, but I suppose what we're saying is that we're producing buildings that perhaps use materials in what we may now consider to be not so much a responsible way. We're using very, very hard materials to do a job that they might not necessarily need to be super, super hard to do. We're expecting our buildings to have exposed eaves and no windowsills and things like that, and that means that they're very exposed, and for that reason the materials have to be very, very hard to deal with that exposure. So I guess we want to challenge some of that. And what we don't want to be is the people that continue to play golf whilst the forest fires are going on behind us. We really want to be addressing this. I think there has also been a bit of it's certainly changing now, but there has been a bit of a kind of idea that, let's say, environmental buildings or sustainable buildings need to look a certain way, and they need to sort of fall into a certain sort of cliche or category, and I think we really want to challenge that. So we produced, alongside some really fantastic material specialists and developers, we produced a different brick for use on a particular project. The project is in Gent. Gent is the capital of Flanders in northern Belgium, and it's a medieval city. It grew out of a kind of trade of cloth right back from the medieval period. It's really, really beautiful. So if you get the opportunity to go, you must. It's only 2.5 hours on the Eurostar. The Design Museum, they have the largest collection of design objects. In fact, they have the national collection of design objects in Belgium, and that ranges back from, say, the 13th century right up to kind of contemporary designers who you may be familiar with. Our site, which has got this white line over it here, is really situated right in the very centre of Ghent, and it's actually within the boundary of the UNESCO World Heritage Site, which is the Belfry of Ghent. So they call it the buffer zone. So it's situated within the buffer zone of this UNESCO World Heritage Site, and there's also a pretty fantastic castle, which is just there. So we're kind of within spitting distance of all these amazing buildings. So we're working in like a very sensitive historic context. The brief for the project was really about infilling a vacant plot on the site of the museum. So the museum is situated around a courtyard. There's sort of 3 existing buildings. So there's this one here, which dates from 1992. There's a building that's kind of obscured by a model, but there's a sort of former hotel, which is from the, I think it's the 17th century. And there's this building, which is known as Huis Leegsten, which is a sort of typical Belgian merchant's townhouse, which dates back from the 13th century. And they had this vacant plot. They basically... This building was built in, as I say, in 1992, and then they ran out of money. The city ran out of money, so this plot has been left empty for the last, 2 decades. And what we've really looked to do is to infill that plot, but also the project reconciles quite a lot of issues to do with circulation, to do with movement of people, and to do with the kind of visibility of the Design Museum. So The brief for this infill, it's not particularly specific. It's about making rooms that accommodate a range of different programs. So the ground floor space can be an event space, it can be a gallery space, it can be a shop, it can be a cafe. As we move up the building, everything's sort of got this loose programming, which enables the museum to kind of host a whole different range of events and also introduce new and diverse and different audiences that wouldn't necessarily go to the museum. In terms of how the building looks and how it sits within the historic context that I've described, we felt quite early on that the building should sort of feel like a monolith within the city. It's certainly not one of these townhouses, and it sits as a sort of almost a sculptural presence within what is quite a kind of busy network of streets around it. In terms of the facade material, we wanted something pale. The reason being that most of the kind of important civic buildings within the city are made of a pale stone or painted white. So there was a sort of nod to the fact that this is an important building for the city. I wanted the facade to be intriguing as well. We also, if you kind of zoom into the scale of the visitor or the person stood up against the facade needs to embody the values of the museum, the values of innovation, of making, of design culture, and therefore something that's intriguing to look at and that's intriguing to touch. And for all of these reasons, and also indeed because brick is such a prolific material within Flanders, it's Belgium and particularly Flanders is very famous for its brick buildings. So for all of these reasons, brick felt like a very appropriate choice. That said, there is a huge embodied carbon impact of using brick, and there's lots and lots of documents and text written about the fact that the production of brick globally is responsible for some insane amount of black carbon, which is like the worst, most filthy, dirty, horrible, polluting type of carbon that exists. So it's not a great material from that point of view. Your kind of typical fired clay brick, it's made with a binder of clay, a silica, which is typically virgin sand, and it goes through a firing process. We've produced a brick that substitutes the clay binder for lime. It substitutes virgin sand for construction and industrial waste as the silica, and it goes through a process of carbonation, which doesn't involve a firing process. And what you end up with is a cured lime waste brick. A little bit on the chemistry, and I'm not a chemist, by no means. We're able to reduce embodied carbon through both the materials that the brick is made out of, but also the process in which it's made. So if we just talk about materials for a moment, we have actively avoided using, as I said, kind of virgin materials. That includes virgin clay, but also virgin sand. The dredging of kind of riverbeds and the use of sand is really problematic from an environmental point of view. It's, rivers are changing course, and biodiversity is being really damaged by us, the demand for sand. So if we can look at ways to make substitutes there, that's a very, very good thing. We're using lime as the binder, as I said. Lime is a product of limestone. Lime does require a firing process. Basically, you produce lime by burning limestone, so limestone the rock. That said, lime exists on a spectrum. So you have pure lime, which is kind of very soft, and it's used a lot in kind of building conservation, and as you might have heard of lime putty. That exists at one end of the spectrum, and the production of that, you actually fire limestone at a relatively low temperature. As you move up this spectrum to lime, you get hydraulic limes, and then you get the sort of limes that are associated with cements. As you move in the spectrum, the firing gets increasingly, the temperatures that you're firing at gets increasingly high, but then also the kind of the characteristics of how the material dries. So lime at this end of the spectrum dries hard, it's non-malleable, and it dries very quickly, whereas lime at the other end of the spectrum, it dries quite soft, as I say, it's malleable, and it dries much slower. Also the compressive strength, the impermeability, the brittleness, and the setting speed sort of shifts as you move up that spectrum. So we talked about the lime, we talked about the binder. In terms of the silicates then, we're using waste brick, waste concrete, and waste glass. So these are all materials that were very, very readily available, and are indeed very readily available as substitute silicates. What we also found that's quite interesting, you know, we need to somehow kind of compress this material and make it all stick together. And we found that when you're using recycled silicates, they have pozzolanic qualities in them, which basically means that they can they assist in that binding process. So if a material's already gone through a firing process, so in the concrete, ceramics, bricks, all of those things have already gone through a firing process, then they inherently tend to have these pozzolanic qualities, which then assists in the binding process. We were also able to source all of those materials from within a very small radius of the design museum. So we're keeping our materials and our sourcing very, very small and tight, and therefore there's less embodied carbon with transportation, there's less need to kind of travel very far, and the movement of very heavy materials very far. So if we talk a bit about the process then, how it's made, it's a kind of small-scale production. I say small scale, we're still producing 100,000 bricks for this project, so it's not insignificant, but it can happen on site, it can happen in a clean process, that it doesn't produce lots of pollution, and therefore we're able to be sort of agile with where that happens. And actually, one of the great things about this project is that the production is going to take place on an old industrial site just on the outskirts of the city. So we're sourcing the materials from around the city, we're also going to be making the bricks within the city. So a few images of the production here. It goes through it goes through a sort of high compression, and it pops out as these modules. It then cures, and what we have is a brick which is approximately 1/3 the CO2 of a sort of standard clay brick, and it looks a little bit like that in the sunshine, which is quite nice. And the little bits of glass that are in there sparkle in the sun, which is very nice. Something I was talking about with Will just moments ago is the fact that the client has kind of been with us throughout this whole process. And what we've been able to do is there's a really beautiful narrative. You basically take waste from the city of Gent, you turn it into a brick, and that brick is then used to build a new museum for the city of Gent. So there's a very nice narrative that the client and also any sort of stakeholders can buy into. And that's been a really powerful kind of tool, and a really powerful way of being able to take the client on this journey. It's really important to stress how critical collaboration is in this process. And indeed, you know, we've been the architects throughout this, but we haven't done all of the making, we haven't done all of the necessarily the material research. We've been working with Local Work Studio, who are based in Sussex, who I would urge you all to have a look at because they're doing some really, really interesting things with waste materials. And we've also been working with BC Materials, who are based in Brussels. BC come from a background in compressed earth construction. They're very, very familiar with with all sorts of regulations, particularly in Belgium. So they've been amazing in this process of developing this material. Ben, as I say, this is Ben from Local Work Studio, does some really interesting things with kind of seashells and taking lime from seashells, and then BC we worked with. And we produced initially about kind of 30 different prototypes. We were then testing them both against aesthetics and also performance. So two kind of very different bricks there. The one on nearest to me has got the kind of green and the brown that you can see. It's actually glass bottles from the food industry, so kind of restaurants and bars, we found that that doesn't perform particularly well because there's too much sugar left on the glass from the alcohol, and therefore you can't actually bind to it. So we've gone through this whole process of where we're looking at kind of different waste streams, and we're seeing what looks good, but also how well it's performing. We've done lots and lots of tests, just to give you an example of all the different tests and the variants of the different mixes. We've taken them to labs, we've crushed them to see how they perform under compressive strength. We've seen the ones that don't work so well, and we've celebrated the ones that have worked. So the ratio lime to waste is 1 to 3. So it's 63% recycled municipal waste, it's 18% binder, and it's 19% fine aggregates. A little comment on red tape. How do you make this stuff happen? And Eurocodes. So as a practice, we're used to building, I mean, we're building proper big buildings now, but historically we've built lots of kind of temporary pavilions that are either on people's private land or that are going to, they're not permanent buildings, and therefore you can get away with using different types of materials. As we're moving into, as the practice is maturing, and as we're building more permanent and large-scale buildings with institutions, with public bodies, we have to make sure that the buildings are going to be fit for purpose and the materials are fit for purpose for longevity. This is a very pixely photo, apologies, but this is essentially, we've been working with the BUTGB, who are the Belgium Technical Board for Construction, and because there are no specific Eurocodes that this brick kind of sits within, the closest in terms of its kind of chemistry is a calcium silicate brick, which is made of lime and sand. The calcium silicate brick goes through an autoclaving process. So and that's distinct to what we're doing. It's not going through autoclaving, I should probably explain, is a sort of steam oven. The brick that we've developed, it doesn't go through anything like that. It's also made from waste materials rather than from virgin sand. And so what we are finding is that whilst it's chemically very, very similar to other bricks that are readily available, it doesn't actually sit within those codes, and therefore you can't make a kind of direct application, and you can't demonstrate that it's fit for purpose against those codes. So we worked with the BUTGB to develop basically a bespoke test table where we took various different tests from various different codes from various different types of bricks, so calcium silicate bricks, but also your kind of standard clay-fired brick, and we therefore, with their technical expertise and with their consent, we were able to say, right, okay, it can align with this, this, and this, and therefore we can demonstrate that actually it is fit for purpose on this project. Oh yes, that was the point on the fact that it's not quite the same as other compatible bricks. So we've got this test table. Just to kind of make a quick comparison to other bricks that are, the clay brick mystique is your kind of buff coloured brick that lots of housing developers like to use. Calcium silicate bricks are the ones that I described a moment ago, kind of lime sand bricks, and then this lime waste brick. And we were finding that there was sort of a little bit of discrepancy in terms of performance around these two areas, so moisture movement and freeze thaw. The freeze-thaw is quite interesting. We live in the UK in a very wet environment, but what we have in the UK that they didn't have in Belgium is very detailed data on kind of weather and areas of the country that face more exposure. What we found through this process is that you can actually start to detail out the need for a very, very hard and a very sort of high-performing brick. So if I just scoot back a few slides, we're talking about this F1, F2 thing. So most of the bricks that are available on the market, you want to perform at F2. However, we were really only getting F1 at one point. the point being that it's interesting in the UK because we have this detailed data about exposure. You could actually refer back to the standards and you could say, well, hang on a second, I don't necessarily need my brick to perform to an F2 standard because I could start to introduce a large windowsill which would protect the brick, and I could put a big coping stone on top, and therefore I wouldn't have such an exposed parapet. And so you can start to kind of use these softer materials and tailor your detailing in order to support these softer materials. And this is the sort of, I suppose, the main like theoretical takeaway that we've had from this project. Sorry, I thought that might happen. So the client asked us to make sure our brick performed to F2 standards, which we've done. But to be extra safe, we've also adapted our detailing so that the areas where the brick is most exposed, we can begin to protect. And what we've sort of found is that we've actually really enjoyed the articulation that the building then has through that process. So the early picture on the left there is an early render of the windows sitting very close to the front of the facade. Later down the line, we're introducing large windowsills, we're introducing large parapets, and we find that we're really enjoying that visually because it starts, as I say, to articulate the facade in an enjoyable way. Similarly, on the roof, we've introduced this very large overhanging eaves and indeed the windowsill here. So some of the detailing, you can't quite read it, it's also some of it's in Dutch, so unless anyone speaks Dutch, we've kind of adapted it, and we've also been referencing like earth block construction methods. What we found is that this sort of detailing becomes increasingly applicable in this process. I guess the point is none of this is also very new. We know that vernacular building and historically, building construction was far more aligned with the materials available, and we were far more sort of it was much more common to see buildings in exposed environments having these sort of high levels of protection. And I think some of this has also been about us kind of thinking, well, hang on, we need to look back to look forward. We need to be, if we want to be building with, let's say, softer materials that aren't so onerous on the environment, we need to be adapting our detailing and our approach to building, and indeed our ideas about aesthetic going forward. So that house you saw at the very beginning of the slideshow that has kind of no protection whatsoever, I think we probably wouldn't want to build like that anymore, because what it demands is this very kind of hard, strong building material that is then very onerous on the environment to produce. So there's our brick once again. And I guess also part of this and part of our thinking has been about the fact that we really need to be having a new set of standards that actually enable this practice to take place. We've been really lucky with this client. We received 100,000 euros of funding from Circular Flanders, a lot of which actually went onto legal fees for lawyers to be able to help us through the process of getting the brick certified. And indeed, it's not certified against any codes, it's only certified for use on this project. What we really think is that there should be a kind of new set of standards that enable architects and designers and material specialists to be developing a different sort of set of materials that are less environmentally onerous available to specify. So we've kind of suggested that we need a new set of masonry standards for a kind of new sustainable vernacular. And I guess just to kind of close off, the project is on site at the moment, so it doesn't kind of end with the production of the brick. We're also continuing, so the building's on site. This is the hole in the ground where the building's going to go. There's a huge crane in the location where the building sits. And we're currently going through quite a kind of interesting process with facade engineers. So we're now working out, well, how can we use this brick? How can we best use it on the facade? How can we avoid having lots of movement joints? What does it look like when you say get to a corner where you might need to cut a brick? And what does the brick look like? So all of that is to say that the kind of journey continues with the building being on site as well. From a different kind of trajectory as well, the journey's continuing. We've recently got some funding from the Design Enterprise Partnership, who are it's through the Design Museum in London, and we're working with Ceratec, who are a kind of spin-off from Imperial College London, and they're developing a different sort of low-carbon binder, and we're looking at low-carbon bricks for coastal infrastructure. So we're using waste shellfish from, or indeed the waste shells from the shellfish industry on the south coast, and we're looking at how we can maybe develop that into a new set of bricks. And that is the last slide. Thank you. That was quicker than I expected.
Would you take some questions?
Absolutely. Yeah, of course. Yeah.
Do we have any questions? Oh, yeah, a question at the back.
Hi, thank you so much. That was really, really interesting. Because it's called regenerative architecture, I was wondering, you're obviously using waste product for the brick, which is amazing. But because regenerative concept is that it can go back, I guess, into this cycle of producing, I guess, another new brick. Is that possible? You're using waste, obviously, but
yeah,
can it go back and be reproduced, or?
You can. I mean, you could crush it and you could turn it into something else. It's going to be constructed using a lime mortar. So a lime mortar enables sort of deconstruction to happen much more easily than, say, a cementitious mortar. You can take the bricks apart and you can scrape off the lime, and that happens quite easily. So you could either take it apart and reuse the bricks as bricks. You could also crush them and turn them into a different aggregate for, say, another brick. Just back to I'll zoom back to the lime spectrum, because it's quite interesting. When you're using, I said that we had to turn this brick into an F2 brick, which meant that actually we were sourcing hydraulic lime, which exists sort of here on the spectrum. If we didn't have to make the brick F2, we could have used a binder, a lime binder that sits more over here in the pure lime department, pure lime end of the spectrum. What's really interesting about lime is that lime exists on a cycle, and you can keep repeating that cycle. So you can take limestone, you burn it, and it becomes, I think it's calcium carbonate, I'm not a chemist. You then add water and carbonate it, so it becomes a kind of hard material, which is effectively limestone again. So you could effectively take the brick, burn it again, and repeat that process. That's where lime becomes like quite an interesting material, because it's effectively, you can just keep going around the cycle. And the sequestration of carbon from when it carbonates is theoretically is kind of then carbon negative to the carbon that's produced in the firing process. We're not using a lime at that end of the spectrum, unfortunately, but you could do the other things. You can take the bricks apart, or you can turn them into something else.
Thanks so much for the presentation. There's some parallels between this presentation and one I received from Armin Taha at this Clerkenwell Design Week, and he was talking about stone bricks and using waste stone facade material cut down to brick shapes. And I was addicted to using that in a project I was working in practice. There were certain drawbacks about its weight and viability on mass use. What would the drawbacks if this were to be mass production be for this certain brick?
I mean, I think the primary drawback is the fact that it's only certified for use on this project. So in terms of a kind of rollout across other projects, you'd need to go through that process. I know that BC Materials, who we've been working with, they're looking at kind of actually making it sort of going into production, I understand. And therefore, there will be, they may be able to get it certified for use in other applications and on other projects. But I think, the primary drawback is the fact that through this whole process, it's been a kind of 3-year research project. It would just be unaffordable and unviable at scale at the moment. I guess theoretically you could do it and kind of look at how you can sort of use localized waste streams and replicate the production dependent on what your kind of localized waste streams are. But it all comes back to the codes, the Euro codes, and the difficulty in being able to navigate what are quite a kind of stringent and onerous set of standards. Any other questions?
Any other questions? I actually have a question. Oh, there's one here.
Thank you for the talk. About the Euro codes, actually. How do you think we can stretch them in here, or maybe, as you said, making some sustainable vernacular for the upcoming built-in environment?
I mean, that's kind of down to you guys. Like, the next generation of architects. I think there's so much that has to happen. Not to say that we shouldn't be doing it, because we absolutely should. I have lots of conversations with people about maintenance strategies. So along with your clients, often developers, whoever's sat behind the money often wants to know that what they're building is going to last for a really, really long time. And I think there needs to kind of be a bit of a shift in attitudes towards, say, maintenance and attitudes towards risk in order for some of this to happen. Some of the conversations we've had with this client, for example, is, and actually, to expand on the answer that I gave to your question, I think the drawbacks are the unknowns, right? It's a new, innovative material. There are lots of unknowns about what it's going to look like in, say, 10 years' time. We're working with facade engineers to kind of mitigate and to understand about how the brick's going to work and how the brick's going to move. We can't guarantee any of that because it hasn't been done before. So the client is taking a very bold and honourable position about risk, and I suppose we need to embrace that as well, and we need to we need to try and mitigate risk, but we also need to perhaps shift our attitude towards precision and perfect fit and making things look kind of perfect and expecting things to be static as well. Like this expectation that buildings aren't going to kind of grow and shift and look different in 10 years' time is false. I think there's a kind of cultural attitude towards that. It's kind of quite difficult to describe, but I guess it's about sort of having those discussions at an early stage and saying, well, the mortar might crack a tiny bit more than it would if we were, say, using a standard clay brick with a cementitious mortar, but let's factor in a maintenance strategy that allows us to deal with that. And those sorts of conversations early doors. And again, what does stuff look like? We always have lots of conversations about aesthetics, and I think, going back to the Earthship slide, there's been a little bit of I love Earthships, by the way. I think they're really, really cool. But for a really long time, where's it gone? I'm not going to be able to find it, am I? You know what I mean by the Earthship, right? Yeah, there we go. So for a really long time, I think there's been a really low bar set around what sustainable buildings look like, and they've fallen into kind of cliches, and there's also a lot of greenwashing. You either have your really sustainable building or you have your building that has some plants on the outside and therefore it's sustainable. I think we need to really be setting the bar really high, and we need to be demanding a lot from our clients, but also our consultants, our engineers, and the people we're working with. We need to keep asking questions about, well, can we do it better? Can we do it like this? Can we make really sensible decisions? that we wouldn't have necessarily made, say, 10 years ago. Keep being ambitious, I suppose. There's a question over there.
Hi, thank you for your talk. Just wondering on the coloration of the brick, if you use different waste materials in the input, does it significantly change it? And if, say, you took an existing brick and used that as the only waste material, would it look like a brick again?
Yeah, absolutely. So the brick is directly is a direct kind of result of the aggregate that goes into it. So if you're using your kind of terracotta-coloured clay, red brick, and you crush that up, it becomes sort of pigmented. What we actually did that was quite interesting, I guess, is you find that pigmentation happens at a certain scale of aggregate. So if you take away the like super fine aggregate that's really, really small, you can sift it away. You then find that the pigmentation doesn't happen so much. So very early on in those prototypes, we were saying, well, let's remove the kind of 0.0 whatever size aggregate, because that will have a bigger impact on pigmentation, because we knew we wanted it to be a white brick. We've also targeted, you can see when you're looking at the brick that has the bottles from the bars and restaurants, that you see the colour of that. So you can control it up to a point. You can't completely control it, but you can target your aggregates accordingly. We're for the Design Enterprise Partnership, we're developing some bricks, and I've just got a message today with some images of those on, and they're quite pink. They're quite nice because they've got crushed bricks. And for that test, we are not really bothered about what the colour is. We're more interested in whether it works. So yeah, they look quite pink.
Thank you. It's a shame that glass brick didn't work, because it looked really cool.
It is a shame. I mean, I must admit, I prefer the whiter one. It's also quite a nice story that it doesn't work because it's got too much beer on it, which is quite fun.
Glass only not work because of the drinks on it? Would the glass alone not work?
Yeah. So the bricks. I'll zoom forward again. The bricks. There's a comparison. There we go. So the kind of final brick, it does have glass in it. It's industrial glass, and it's ground in such a way that it ends up with the kind of smooth surfaces are taken off. This one, you're right, it was in part because of the kind of sugars, the residual sugars, both from the beer and also from the stickers that you get on your beer bottles. But also you can see that they're quite shiny, the actual fragments, and because it's so smooth, you end up with nothing that the binder can kind of key into. So there's a whole kind of world of science behind aggregates, and I mean the same applies to anything kind of concrete and stuff as well. But you'll find that your aggregate needs to have a sort of buffed surface, and also not be too much like shards, because otherwise the binder can't sort of bite into it in such a good way.
And with fired brick making up so much of the identity of London's buildings, can you foresee the outlawing of fired brick in London anytime soon, and just like the complete replacement from fired brick, so really high embodied carbon, to waste brick or another sort of brick anytime soon?
I can't see the planners outlawing brick anytime soon. I just think we need to be challenging some of this. I mean, a lot of London won't actually be brick. It will be brick slips that are on a sort of prefabricated section of facade that kind of gets offered up to a building. So it's not kind of true bricks. I think that, again, I was having a conversation with someone from Camden Council the other day, and from the planning department, and I guess they were saying, well, more options need to be offered up. I think we need to be, as designers, and there's lots of fantastic designers already doing this, and we should be doing more, but make really compelling arguments for why stuff maybe shouldn't be brick. It shouldn't just be a default. Or indeed, if it is brick, can it be a different sort of brick? Can it be a reclaimed brick? Something we actually wanted to do on this project was use a lot of the reclaimed bricks that were coming off the building. Unfortunately, there's legislation which prevented us from doing it. So we're using it in other applications. We're using it within the landscaping strategy. We're also crushing some of it up and we're turning it into, there's a kind of column on the ground floor, which is going to be a sort of real focal point for the ground floor orientation of the building, and we're using some of the existing bricks and we're crushing them and we're turning that into a column. But it's all of these conversations. How do you make compelling arguments for all of this stuff? And we should be using stone. Stone. Stone is cool. I saw some of those stone bricks the other day at the stonemason's yard that I think Amin Taha.
Lovely, but it's so heavy, so it can make a compelling argument for the transport.
Yeah.
And it has an effect on the bricklaying as well.
Yeah.
Such a shame, because they're wonderful, especially the untreated, uncut facade of the brick.
Yeah.
Really impressive.
Something that we're doing in our kind of next bit of research with Ceratec is we found that actually the binder is actually quite light. So the bricks will be much lighter, which might not necessarily affect their compressive strength. We don't know yet because we haven't done the tests. But if you have a more lightweight material, then the impact is that you don't need then such big foundations. And you're using less concrete in your foundations, and you can sort of build in a more lightweight way, which is good.
Well, look, thanks so much, and thanks for the questions as well. Thanks for, and thank you for such good answers. Yeah, I just wanted to thank you, but also just ask how much does a project like this in your office affect the rest of the office work? Is everyone looking at what you're doing and thinking about the materials they're choosing and why and how?
I think we, as an office, we have an attitude towards innovation and new materials. This isn't the only sort of bit of innovation that we're doing on our projects. I think certainly we have found that there's quite a lot of interest and there's quite a lot of interesting conversations that are coming out of this, and it's making us. I guess it also falls into a sort of much broader movement across not only our office but the industry in challenging seeing the challenge of, say, the climate and biodiversity crisis, seeing that as a kind of opportunity rather than as something that we kind of have to oh God, we've got to adhere to this. It's really how can we embrace this really difficult challenge, and how can we be really ambitious with our buildings and make we talk about it a lot, how do we make the things about kind of sustainability in the environment, how do we make that intrinsic to what we understand as being a good building? For such a long time it's been seen as a sort of optional add-on. How do we make it intrinsic within our understanding and our, how we fundamentally think about our buildings as being kind of good or bad? It's as basic as, is it accessible? Does it have great light? All of those sorts of things. It needs to become intrinsic in those ways. And I really think that we're moving very quickly in that direction.
Well, thanks very much. Thank you.